Biostek Dental Technologies, Precision Dentistry Redefined.
CFX method of building and displaying computer 3D models of temporomandibular joints, TMJ. New method of visualization and analysis of TMJ. In today's dentistry, during orthodontic and prosthodontic treatment, special attention is paid to the position of lower jaw in space. To allocate mandible into optimal treatment position, it is essential that neuromuscular status is considered along with precise control of condyles position in TMJ fossas. It is crucially important to visualize movement of condyles in TMJ fossas during mastication. Let's look at the existing solutions of displaying tracking of mandible movements on computer, which are based on obtaining 3D models of TMJ using auto-segmentation method of CT. Displaying movements of mandible in space, the possibility of tracking the movements of 3D models of condyles in articular fossas is assumed. Let's take into account the fact that 3D models obtained are significantly distorted and do not match with the true morphology of TMJ. 3D objects obtained show either excessive volume and condyles are not separated from fossas, or separation of models is achieved with significant reduction of volume and formation of voids. Let's take a look at the algorithm used in commonly known solutions. Mandible movements are recorded with special devices. 3D models of dental arches are integrated into CT scan data. In software, 3D models of condyles in articular fossas are obtained using auto-segmentation method. So how does auto-segmentation work? How precise are 3D models of TMJ? To understand the level of distortion used with auto-segmentation, we asked several specialists, radiologists, orthodontists, and prosthodontists, to come up with cross-collegial mutual decision and in manual mode to put down contours of condylar borders and borders of articular fossa. 9 contours were drawn in sagittal projection and 3 in frontal projection. 3D model of TMJ was obtained as a result, which demonstrates how identically and precise doctors interpret CT data when analyzing TMJ. Now we can compare true morphology seen by doctors with models that are obtained with common CT auto-segmentation methods. Let's take a closer look at commonly used auto-segmentation method and analyze problems with this technological solution. What can simply be said about auto-segmentation? Auto-segmentation and obtaining of 3D objects from CT is based on the brightness analysis of tomography image points. Gray color gradation analysis. Bright or white is a solid tissue, dark or black is emptiness or voids. This example shows the setting of auto-segmentation threshold, the threshold range. This is a real clinical case demonstration. We have a CT scan of an acceptable quality where narrowing of a joint space is present, along with condylar shift distally. In an attempt to adapt the segmentation map along the border of a condyle, border of fossa is lost in the anterior region. Note the yellow cursor. The border of condyle and the border of fossa that are lost. Notice that in the area pointed by cursor, the margin of condyle is not recognized. Attempting to adapt the segmentation map to the anterior border of fossa, we get excess volume in other parts of fossa, alteration of condylar borders, merge of borders of condyle and fossa, the presence of segmentation map islands that are not related to segmented object in this task. The data that is obvious to the doctor and interpreted as a joint space, border of a condyle or border of articular fossa on a particular slice, is not caught by auto-segmentation systems. The precision of contouring of objects comes down to a large enough error of 1 mm or more, which inevitably leads to a significant distortion of volumes and inaccuracy in constructing the layout of 3D models of TMJ. Now let's get back to an earlier slide with 3D models. We have either excess volume and merge of condyle with articular fossa, or we have reduced volume and voids but able to separate the objects of our interest. Green 3D models on the left are separated for the price of reduced volume. Condyle is separated from the fossa. Significant distortions are present. Conveyance of true morphology of anatomical structure is failed. Beige 3D models on the right. In an attempt to obtain a precise configuration of objects, we get excess volumes and separation of condyle from fossa becomes impossible. Also known are methods of manual paint of objects or methods of manual correction of segmentation map on each separated slice of CT scan in 3 projections, but it takes hours of working time, and those are irrational in clinical practice. In known methods of displaying tracking of mandible movements on computer, in fact we see the movement of a significantly distorted 3D models of TMJ, which greatly reduces the scientific and clinical value of known methods. All softwares bear the same problem of precision of 3D models of condyle and articular fossa. This is due to the reason that the evaluation of trajectory of movement is used by the means of one point tied to a condyle. To evaluate movements of complex 3D object, it is not enough to represent this object in the form of one point. At Biostek-DT-Eng, the task was set to develop a method that allows to quickly obtain precise 3D models of condyles and articular fossas of TMJ from CT scan. CFX method. Let's analyze the CFX method and create precise counter 3D models of TMJ. On standard 3D scene comprised of computer tomography and integrated 3D models of dental arches, visualizing the right TMJ zone, condyle is split into 8 equal parts in axial projection, marking the separation boundary with control labels from outer margin marker 1 to inner margin marker 9. Beginning from outer margin on first boundary of separation, operator manually creates the contour of condyle and contour of fossa in sagittal projection. 3D contours with 100 microns in diameter are automatically created in 3D scene. Moving along the separation boundaries from first to ninth in axial projection, operator in sagittal projection creates 9 contours for condyle and fossa respectively. 9 3D contours are automatically created in 3D scene. Then the operator, using definite sequence, adds 3 contours of fossa in frontal projection. Such-wise, highly precise contour 3D model of right TMJ is obtained. For left TMJ, the sequence above is repeated and respectively, highly precise contour 3D model of left TMJ is obtained. Now, in 3D scene, there are dental arches of mandible with precise models of condyles as an object of movement, and static objects, dental arch of maxilla with precise models of fosses of TMJ. "3D models are allocated in a specially designed window interface for convenient visualization. Monitor is split into several working zones. Sagittal contours of right TMJ display zone from 1 to 9 from outer to inner margins of condyle. Sagittal contours of left TMJ display zone from 1 to 9 from outer to inner margins of condyle. 3D view of joints right and left display zone. Frontal contours of right TMJ display zone. Frontal contours of left TMJ display zone. Overall 3D scene display zone. Interface can be modified depending on the amount of contours and the size of the monitor. This visualization allows precise control of movements of condyles in respect to fosses of TMJ during mandible movements. In this clinical case example, we did not use recording devices. To analyze the situation of a patient, standard gnatological positions of mandible that are used in assessments were integrated into 3D scene. Protrusion, the movement of mandible forward. Resting or slightly open position. Right lateral protrusion, side shift to the right. Left lateral protrusion, side shift to the left. Complete diagnostic 3D scene is created with possibility of detailed analysis of TMJ. To show the example of visualization, let's take a look at mandible protrusion position. Evaluation of 3D models of right TMJ shows side shift of contours of condyle outward. There is a possibility to evaluate the movement of condyles on the level of each individual 3D contour. Precise control of distance and joint space on any side of interest. Exceptional level of precision in visualization. Demonstration of selected mandible treatment position. Model with plant movement and control of condyles relatively to fosses of TMJ. CFX is obvious advantage in precise visualization and analysis of TMJ compared to available alternatives. CFX can be used in clinical practice as an independent diagnostic software model, but its maximum efficiency can be achieved by integrating it with systems recording displaying movements of mandible. CFX can be integrated into any protocols of treatment, gnatological, neuromuscular, or a combination of both. Utilizing CFX method in clinical practice allows to create highly precise 3D models of condyles and articular fosses of TMJ with thickness of contours and diameter of 100 microns. Precisely set mandible into treatment position and fabricate various restorations. Avoid distortion when obtaining 3D models of TMJ using common methods of auto-segmentation.